We start our lecture. So today is the 19th, October 19th, 19, okay. So it's week 7. So suppose we need to finish the SIFT. So right now we are at the stereo, so a little bit delay. And next week we are going to give you the first assignment. Next week we'll give you the first assignment here. So you need to spend 2 weeks working on the assignment. So we continue our lecture about stereo. This one. So we already talked about what is the stereo. Basically, is that we have a 2 camera, but actually stereo will more than 2 cameras. Like right now, we have made multiple cameras, 10 cameras, 30 cameras, a lot of cameras. Okay, but two camera can be one stereo, and you use the RealSense. Right now, RealSense is popular. Previously, people use Kinect. Okay, Kinect 1, Kinect 2, and right now people use just RealSense by Intel. Kinect is by Microsoft, and the price is cheap. So RealSense is based on the stereo. So inside the RealSense, there are 3 cameras. 2 cameras for the stereo, display value camera, and one more camera, RGB camera, is for color. Okay, but why they want to use the gray color stereo camera? Because it's easy to find for the calculation, and also it's cheap. Okay, so it's 2 camera like this way, right? So we have left side camera, we have right side camera. And the theory for the stereo is easy. Just find the corresponding point. So the theory or the formulate for stereo is the same point here, and we try to find the corresponding point. And based on the distance, if the object is closer to you, they have a larger, we call parallax 视差视觉的跳动的视差。That's disparity. Disparity is the distance between 2 corresponding points. So if the object is far away from you, the disparity is smaller. So based on this kind of theory, we can find the depth. If the object is more far away from you, probably the disparity is 0. That's meaning it's far away, or even if infinity points. Okay. So all the stereo is try to find a corresponding point. So there's one example here. I show you. There are several examples. So this company in Taiwan, they are developed the chip. So they work with my lab. So we have a stereo here, Just about 10 years ago, we have a stereo. This one is before the real sense. So 2 camera here. Okay. And they can do the real time. So the object, this person is here. 这是大概10几年前那个预创跟我们实验室合作的一个晶片的东西，它最后被 RealSense 打败了，就他有做出来，但是不知道最后为什么被打败了。So you can use your body to control this target. They also can do the gesture. So they are doing a good job for this one. So stereo can do the real-time thing. But it's not easy because you need to compare each pixel, the corresponding point of each pixel. So it's time consuming. But this kind of process can use the FPGA because we can do the parallel processing. This is the other example, front of the TV. So you can use gesture to control the TV. So above of TV, there is a set of a stereo camera. But because TV is very cheap, so stereo like a morning 10,000 NT dollars， 它1万多块嘛。那现在那个 TV is cheap， so this doesn't include in the TV, but this idea is good. Okay. So you can use gesture to control based on the stereo. And later on, right now the car, they apply a lot of stereo things. There's Mercedes-Benz. Okay. They have a stereo here. What they did is they try to detect the flat of the road. 它去侦测那个路的平面啊，平面。So if the road is not so flat, this one, they can control that one. So inside the car, it will be very smooth. So this very good product by Germany. So this one, this one, they detect the fate of the road and then they control that one. Okay, so very smooth. So this is an intelligent vehicle. So those applications are the stereo. So back to here. And right now, because the camera is very cheap, so in the car there are probably more than 7 cameras. 就现在因为太便宜了，所以车子里面到处都是摄影机，很多。So first of all, we talk about the equation or formulate of the stereo. So is this equation? So when our purpose is try to estimate the depth z. The depth meaning the any pixel in the world, the distance between the pixel and the camera. So suppose in the world, the pixels here, any target, any object, in the surface they have a pixel, and the camera is here, stereo camera is here. So this camera 1, this camera 2, and this virtual image 1 and virtual image 2. what you can see is the image. So how can we estimate the z? Okay, so the equation is in the next one. Okay, so we need to know the distance between two camera. That's called baseline. You design. So the distance between two camera is based on what you design. If the distance is away, far away, the distance here, we call baseline. If baseline is a part wider, and then you can see a far away object because this is longer and this will be far away. Okay, so probably in the car there are different kind of stereo. Some stereo they have a shorter distance. They can detect the closer object. Okay, some stereo is between two distances far away, so it can detect further distance. In the satellite, they have a stereo on the top, so they can estimate the surface of the ground. Okay, but the distance is several kilometers away. 那个卫星好的美国的卫星他们是有那个 stereo， 那我在美国是有看过，它可以把表面上的 3D 全部扫描过来这样子。We back to here. Okay, so we have a baseline and we will try to estimate the distance between the object to the camera. So it's z. And f is the focal length of the camera. So f is here. Okay, and the d we call disparity, as meaning the distance between two pixels. It's 2 pixels. So our formulation is this way. So we use all the 3D things are based on the triangulation. Okay, so we have the first triangle is this one. So B is here, Z is here, and B usually is centimeter, Z is the is meter. Compare with the other, this one, this distance, this small triangle. So that's meaning this Z is bigger one. Compare with B equal to Z minus F. Z minus F for this one. So this the red triangle, okay? And B minus this one. This is a distance. So this is a B minus this part and this part, both parts. So become this distance. Okay. So what's the D? D we call disparity. So suppose in the U1, the image 1, we have a point here. In the U2, we have a corresponding point here. So the distance between two corresponding points that we call disparity D. So this one. And this can estimate based on the two images. Okay. So finally, we got this one. So this is the final equation for the stereo. But be careful is B is a centimeter usually. F is a millimeter focal length. Okay, we want to estimate the distance between the object to you. So that's either meter or centimeter. And the unit for the pixel is a μm, micromillimeter. Okay. So our problem become, how can we find the corresponding point? Okay. So how can that's a matching problems. And matching is a similarity. Matching is kind of a similarity. 就是我们找那个相似可以 match 的点 matching point. So detection, tracking, recognition, all are based on the matching, or the similarity problem. That's a matching problem. Okay. So before we talk about the corresponding point, we would like to introduce one we call epipolar constraint. Why? Because when we at one point here, suppose you have one point, you have a 1 point pitch here, or a pitch here. How can we find the corresponding point to this one? Basically, you should search from top left. You have a small window called template. If you search one by one, using Scanline to search and find the corresponding point, find the best match. That's 2D search. So any detection matching is 2D search. But in stereo, that would take too much time because each pixel you need to find corresponding point. It will take a lot of time, so that's no good. So how can we reduce the 2D search become 1D search? 1D search meaning if I can align two lines, this line and the corresponding line, we can align two lines, alignment, align well, and then this point you can find just directly along this direction and find a corresponding point. That'll be better. So for the stereo, we don't do the 2D search. We try to find the corresponding line we call epipolar line. So each line here, we try to find corresponding point here and then just do the 1D search. So it will reduce a lot of searching time. Okay, that's stereo. So our purpose for the matching we try to do is that we try to apply 1D search instead of a 2D search, and we call this one called epipolar constraint. Okay, so what's epipolar? So we have a stereo, camera 1 and camera 2, and this is baseline. And this is 3D points, any 3D points. So the 3D point we project to the camera in the image plane. We have a projection point we call P left. In the right hand side camera, we have the other projection point we call P right, PR. Okay, so with 2 points. In the camera left, in your right hand side camera center, you have the other projection point to here. From this point, you project to the camera left, you have this point. This point called epipole. We define this point called epipole. And the other C left also have the other epipole project on the right hand side camera. We call epipolar right. Any image there is only one epipole. Any image has only one epipole if you have a 2 camera. So if you have 3 camera, there was the additional 2, but don't care about that. It's just each time for stereo, only 2 camera, only a pair. So if you have the 3 camera, you only choose 2 camera to do the stereo, and the other 2 camera for the other stereo. Okay, so right now we have a epipole. So any point, if you connect with the epipole, this line we call epipolar line. Okay, so if we have, I could jump to the page 31. So suppose you have 2 points. So the first point you project on this green dots and the other green dot. Okay, and there one epipolar line here, and their corresponding line, in the other side, we also call epipolar line, but this corresponding line. If you have the other point B, you project on the image plane. Suppose you have the yellow one. The The other one is this one, yellow one. So this is the other epipolar line. So that's meaning any 3D points, if you project on the image, there exists one point. And this point, if you connect with epipole, that's epipolar line. So if they have a, suppose 10K points here, the resolution 10K, each point, if you connect with the epipole, they have one epipolar line. And in the right-hand side epipolar line, sorry, left-hand side epipolar line will corresponding to right-hand side epipolar line。就是说，你假设你的影像里面是10K 好的解析度，那每一个 pixel 可以跟 epipole 连接成一条，称为 epipolar line。那你左边有一条，你对应的点一定会出现在右边那一条上面。你左边的那一条 epipolar line 的那一点，它对应的右边的那个对应的点一定出现在对应的 epipolar line 上面。那你这边假设你有10K 个点，它就有10K 条 epipolar line。那每一条会对应自己的另外一个对应的 epipolar line。So any points in the left-hand side, you connect with epipole. That's called epipolar line. In the left-hand side epipolar line, that point is corresponding point to the right-hand side image. That corresponding point connect with the right epipolar, the other epipolar line. So two epipolar line will be correspondence. 两条会对应。So that's meaning if you can find the corresponding epipolar line, that's meaning in the left-hand side any point, you just go to the corresponding epipolar line in the right-hand side and just search 1D search along the epipolar line, you can find the corresponding point. 这样子，所以 epipolar line 很重要。They can reduce a 2D search to 1D search. Okay. And this plane, the capital P and C, left CR, this plane called epipolar plane. So epipolar plane, they will intercept with image. This intersection line we call epipolar line, and both epipolar line are corresponding. 这两个是对称，那个对应的这样子。好。So what's the geometry of epipole? That's meaning if you have a two camera, these two camera, what kind of a situation will happen? So first situation is that if you want to see an object there, and these two camera are not parallel, so they have an angle. This is best. The best situation is the situation 3. There are 3 kind of a stereo setup. 就你在做 stereo 有3种设定的状况 ，3 kind of a camera setup for stereo. The best one is this one. The third kind is that if two camera are parallel to each other, that's best situation. I will explain to you soon. Okay. So the first situation is this one. Sorry, if two cameras are not parallel, they have some angle. Okay. And the second situation is one camera you want to see here, one is parallel, the other is have some angle. This is if I want to see front of me this way, and the other camera is this way. So first situation is that two cameras are not parallel, and we need to do we call rectification. We need to do this way. So that's called rectification. Later on, this one. If two cameras are not parallel, we want to do is a project on the parallel plane. This is called rectification. So the first situation is this one, and we need to calculate based on extrinsic parameters of between two. They have a rotation translation between two, so we can rotate to the parallel. We call rectification. It's very important. Okay, so all the stereo are based on the parallel plane, image plane. 就你所有的 stereo 基本上都是希望在一个同个平面上做，那是假的，所以你要去把它投影过来。好，那我刚刚讲了，那我们有3种状况。好，所以 the first one is this situation, right? And you should do rectification to the parallel. Okay. The second plane is like this way. You want to see here. The first one is this one is you want to see this direction, so it's this way. The second situation you want to see this based on this one is front, and this has some angle. So this one you should project on the parallel, project to here. Okay. And the third situation is the best one is this one, parallel. So 第3种是最好的，也是我们要做的。好，那我们再回到这一边。So the first one, you will find, so the first situation, we will find the epipole, this one, E1 and E2. You can see in the image plane, there exists an epipole. 就第一种状况，你会发现它的 epipole 是在影像里面。The second situation is this way, right? So there exists an epipole here, but in this parallel, the epipole is in the infinity direction, in infinity position. 就这个 epipole 这个会在无穷远的地方，为什么？因为这个 C2 对不对 ？project 到 C1， 但是因为平行，所以它会 project 到无穷远的地方。So in the second situation, the E1, the epipole will locate in the infinity position. In the situation 3, both epipole will locate on the infinity position. 因为你的 C1, because your C2 will C right will project on the C left, but because the parallel, so it project on the infinity position. 你把它想成这个地方。If they are parallel, what's the definition of epipole is C right project on this image plane, but the image plane is parallel, so you project on infinity position. 这样子。Okay, so you have 3 situations for the stereo setup. So after we define the epipole, our purpose is try to find a epipolar line. 你要定义 epipole， 记得我们讲到 epipole 的目的要做什么？就是要找 epipolar line. So what's the epipolar line? Is meaning, I say again, what's the definition for epipolar line? It's meaning because if 2 corresponding points are suppose in the left hand side, you want to find the corresponding point on the right hand side, but you cannot find. It's not easy to find because you need to do the 2D search. That's take time. So we want to reduce the 2D search become 1D search. So that's meaning because each point in the left hand side, they have one epipolar line. If you can find the corresponding point in the right hand side epipolar line, and the corresponding point will locate on the right hand side epipolar line. 就你的2个对称点一定会同时出现在对应的 epipolar line 上面。你的对称点一定会出现在对称的 epipolar line. So our purpose is for each point each point we want to find the corresponding epipolar line， 这是我们的目的。好，那 so in order to find the epipolar line, we need to teach you what is we call essential matrix and the fundamental matrix. We need to teach you this way. So in order to find epipolar line, we need to teach you what is the essential matrix, what is the fundamental matrix. In OpenCV, they have a code. They already are coding for you to find epipolar line. So you don't need to do the programming by yourself. No, you just call the function. They can they can show you the epipolar line. Okay. But inside the epipolar line, the calculation, I will teach you what is the essential matrix and fundamental matrix. Okay, so in order to find the epipolar line, we need to teach you the fundamental matrix and essential matrix. So again, in this figure, we have a P, 3D P, and based on the left-hand side camera, this P we call P left. Based on the right-hand side camera, this called P, capital P right. So P left, and what's the A? A is the intrinsic parameters. So I already teach you the camera calibration. So based on the camera calibration, the chessboard, suppose you already, or for each camera, you already know the intrinsic parameters A left, in right side A right. But usually, when we do stereo, two camera, we will use the same type of camera. Otherwise, you'll cause some trouble. 就我们在做 stereo 通常是让摄影机是同样型号的 ，but each camera has a little bit different about the intrinsic parameters. So we need to do the calibration for camera intrinsic parameters. So the 3D project on the 2D. So this point in image in the left-hand side we call small p left L, and then in the right-hand side we call P right. And then the relationship between these two camera, the corresponding point in the 3D, so is extrinsic parameters. So in the 3D, any 3D coordinate, camera coordinate, any coordinate in the 3D, okay, they exist rotation, and translation. So the P left after the translation, this translation T equal to baseline, because the translation is between the distance between the camera 1 and camera 2. Okay, so that's the base. So baseline is the T, and then rotation. So based on the chessboard calibration, do the stereo, it's easy to find the intrinsic parameters for each camera and also extrinsic parameters. And OpenCV provide you this kind of a calibration for stereo calibration. OpenCV 有提供你 stereo 的校正哦。If you have more than 2 camera, it's also fine. Use the chessboard. You can calibrate each camera and also their rotation, translation, extrinsic parameters at the meantime. So after you do the stereo camera calibration, you will find each camera, the intrinsic parameters and the extrinsic parameters between 2 cameras. So you have all the information. So based on this information, the first one I would like to teach you is the essential matrix. What's the essential matrix? Is this one, E. So what's the E? E is a 3D point XYZ in the right hand side and 3D points in the left hand side, there exists an essential matrix. This is the 3 by 3 matrix. Okay, this one, and will let this inner product become 0。就内部这个基本的叫 essential matrix， 它是存在，它会让这个 equation 变成0。意思是说 if you know E, any point on right hand side, you can find the corresponding point on left hand side. If you know E, so what's E? So here's the try to prove is that if we have a P left minus T, this one, what is this one? P left here. In this side, P left in the camera left hand side, P left minus T. That's meaning you have this direction, right? This P left is this direction. Vector P is this direction. So you do minus is mean the other one is this one. P, that's PL. Okay. And then you times the cross product T cross product P left. So that's meaning you have this one minus this one. You also have a cross product is this direction. So this result, this direction will be 90 degrees of this direction. 对，这是你的相减嘛，那这是你的外基，那外基的方向刚好跟这个平面成90度，所以the inner product between both will become 0. And what's the T cross product with the PL? This is a cross product. Any cross product can represent by inner product format. 任何外基的形式都可以用内基来表示。这是外基嘛？那任何外基它都可以用内基3×3的形式来表示，那这是内基的形式。这 Jacobian 的东西。那这个上网络找得到，我就不讲了。好，那就把这个当成一个3×3的 matrix， 3 by 3 matrix。好，那 what is this one? This one we can instead here. So P left minus T equal to P right inner product with the R transpose here. So become R transpose here. Okay, so this term become this term. And then we put the capital PR out. So inside here become rotation, inner part translation. So essential matrix is the rotation times translation. So the extrinsic parameters. So that's meaning in physical meaning, 物理意义是这样讲，就是说 in the right hand side camera, any point, after you do rotation and translation, that's meaning essential matrix, 3 by 3 essential matrix. You continue to inner product with the P left, the result will be 0. This E called essential matrix. That's meaning if you do the calibration, you have a rotation and translation. So that's meaning in 3D, you can find the corresponding point between two. Okay. So this is 3 by 3. This is a 3 by 3 matrix, right? So how many corresponding points you need to have in order to solve this equation? You need 3 corresponding points, right? Because 3 corresponding points is a plane. So this plane here, this the other plane here. And your essential matrix is 3 by 3 elements, 9个未知数嘛。Now for each 3D points is the x, y, z, become 3 equations. So you need to have more than 3 corresponding points in 3D, you can solve the eccentric parameters. So when we do the calibration, the chessboard has many points. So you can optimize to solve the eccentric parameters. This one, so as essential matrix will include rotation and translation. But the problem is this one. What we can see is only image. We don't know 3D things. 来，你现在看到都是影像啊，你拍照片都是影像，你看不到3D 的东西，那怎么办？ So essential matrix in reality it doesn't work. You cannot find corresponding point. So we have the new one is that we call fundamental matrix. So what's the fundamental matrix? Is that okay? 3DP project based on the intrinsic parameters you project on 2D. Small p r, and the other side is small p left. Okay, based on the intrinsic parameters of camera. So you reformulate this one, you'll find out your fundamental matrix F. If you can find F, that's meaning in any right-hand side point, you can find corresponding point in the left-hand side. If you can find fundamental matrix. So what is a fundamental matrix? Is a intrinsic parameters, extrinsic parameters, intrinsic parameter again. That's meaning in the right hand side, any 2D points, you based on the intrinsic parameters, you reproject on the 3D. So here is 3D. And rotation, translation to the other domain, the other coordinate in the left-hand side, and it project to the left-hand side camera image plane, become corresponding point. That's called fundamental matrix. 就是说，这个我们来物理意义来解释的话，很单纯，就是你右边的任何一点，你先把它 reproject 到 3D 去。那 3D 经过，因为有外部参数，你经过 rotation 呈现，已经转到另外一个坐标了。在另外一个坐标，你再把它 project 到它的平面上 image 上，就找到对应点。好，所以理论上，你如果找到 fundamental matrix 的话，它会有一种现象，就是你的2D 任何点乘上你的 fundamental matrix， 这是3×3的矩阵，然后你会找到对应的点在这里，那这个乘起来会等于0。那这个叫那 epipolar 的东西，这样可以哦，就靠找到对应点，这样。好 ，So the most important one is fundamental matrix. So based on fundamental matrix, you can find the corresponding point between two camera. But you need to what you need to do is calibration. So how can you find the fundamental matrix? You need to know the intrinsic parameters. You need to know extrinsic parameters. You need to know the other intrinsic parameters. So those fundamental matrix elements, you need to do the calibration, stereo camera calibration. 只要做校正，就可以找到了，这样子。好，但是在实际上 ，in reality, even though you find fundamental matrix, you still cannot find corresponding point. You still need to find the epipolar line first. Now, after you find epipolar line, and you along the epipolar line, you try to find the corresponding point. 就是说，这是理论上是可以，这是对的，但实际上这还是找不到。你还是要先找 epipolar line。那 epipolar line 是在这里，这条 epipolar line 上你要先 ，if you want to find epipolar line, you need to find fundamental matrix. Also, you need to find the epipole, and the cross product will be with the point will become epipolar line. But don't worry about this one because OpenCV already write those code for you. OpenCV 已经帮你写好了，你 code 它就会帮你把 Epipolar Line 找到这样子。好，那这是基本上 Epipolar 的目的。那最后这边我们要教你是刚刚讲的 rectification。So rectification meaning any pair of camera we call stereo. If you try to find epipolar line, you need to do this way. Parallel. So this R is the fundamental matrix R, the same. 这 R 是 R 这边，就你要把这个两个 R 找到嘛，那你 R 把它平行。那这个就刚刚讲的那个外部参数，这个可以找得到哈。所以 stereo 的 rectification 实际上就是找外部参数。你这是可以 chessboard 嘛？那你可以根据这 chessboard 就可以找到这两个之间的 rotation， 这样子啊。好，那我这个就so we already support. So after you find the epipolar line, okay, how can we find corresponding point? Okay, and here the matching method, there are different kind of method. Some is dynamic programming, some is graph cut. They are famous. 这两个还蛮有名的。So what's this one? So support we have stereo here, and this is the ground truth of disparity because our purpose is to try to find disparity. So we try to find corresponding point. We try to find corresponding point. This one, the same. We try to find corresponding point. So how can we find corresponding point? Based on this is epipolar line. So how can we find corresponding point? So we have two things. What's the window size you want to have? So usually the window size is 3 by 3. 5 by 5 is a little big, but sometimes 5 by 5, but that will take time. So 3 by 3 is better. And you have search along the epipolar line. So if this is just for example. So if the window size is important, so if window size is 3 by 3, in this stereo, you'll find the disparity, the depth, exactly this way. More in detail. If your window size is too big, you'll find more global information. You'll lose the detailed information. So window size for try to find corresponding points is very important. And so my experience is basically 3 by 3 is good enough. So the same as filter, the deep learning filter usually 3 by 3 is good enough. And what's the estimation method? We use the SAD, 就两个相减取决的. So this is good enough. Don't use this one because this take time. This also take time. So both are for the similarity measure 1, 2, 3, 4. So this inner product and this more precise. This is we have a normalization. But for the stereo, we just use SAD. It's good enough. It is fast enough. Don't use this one. Don't use other three. They are too slow. You cannot do it in real time. And SAD can do the real time. So the difference. So you try to along the baseline. Along the epipolar line, you try to find the minima value. 就是说你现在开始摄取了嘛，那你摄取的话，你就沿着这个那个 epipolar line. So suppose you want to search 64 pixels, and you along this 64 pixels along this epipolar line, you try to find the mini one, minimize one. Minimize one is mean the best match. So each page, you project to the corresponding epipolar line, and then you along the epipolar line you search 32 pixels or 64 pixels. You search that one, and you try to find the minimum value of SAD. That's your best match. 找最小值，最小值这两个相减就最小嘛，就是你的 best match. So usually we use this one. Okay, so that's almost done for the stereo. Stereo 大概就是找这样子。那我待会再稍微讲一下，我们就会把它结束掉。So we take a 10 minutes break, and we'll continue and to finish the stereo lecture.